In SOLIDWORKS, mold tooling is designed around the solid model of the plastic part to be manufactured. Because of this, it's important that the part itself be designed in such a way that it can be molded. One factor affecting whether or not a design can be molded is whether or not it can be ejected from the mold. This can be determined by using draft analysis. Let's use draft analysis to make sure this part is properly drafted. The first thing I'll do is to customize the command manager to add the molds toolbar. This is a toolbar that contains many of the features we'll be using during the next few lessons. I'll click the icon and the draft analysis property manager appears. In order for this analysis to run, I have to specify the direction of pull. This is the direction in which the mold will be pulled away from the part. You can select a line, edge, or planar face to specify a direction of pull. Because of the nature of plastic parts, many of the faces and edges available could be at slight angles. To ensure you don't accidentally choose an incorrect edge or face, I suggest selecting one of the default reference planes. For this example, I'll choose the top plane to specify the direction of pull. As soon as I select it, notice the analysis runs automatically and displays the part in a few different colors. I'll discuss what those colors mean in a second. But first, notice there's an arrow in the graphics area that shows the direction of pull. If you wish to reverse the direction, you can click the Reverse Direction button in the Property Manager, or you can click on the arrow in the graphics window. There's a checkbox here to enable the adjustment triad. This allows you to adjust the direction of pull by moving the triad in any direction. For this example, I'll keep the direction of pull normal to the top plane. Next, I'll specify a draft angle. This is the minimum angle of draft required for a face to be acceptable as properly drafted. Of course, you can set this to whatever angle you wish based on your experience in the mold making field or by consulting your mold maker. I'll set this to 1 degree. There's an option here to enable face classification. This will result in a face-based analysis where entire faces will be classified to fit one of the categories below. If you check this option, you can also enable the option to find steep faces. I'll enable both options. The only other option I have is to modify the colors used to identify the various faces. I'll leave those at their default values. Notice SOLIDWORKS has color-coded the faces of the model, indicating their different classifications. The first classification is positive draft. This indicates that the faces colored in bright green meet or exceed my 1 degree draft criteria, and the mold can successfully be pulled away in the direction of pull I selected. Next is requires draft. This classification indicates that the 1 degree criteria was not met, and consequently, the mold part will not easily eject from the mold. The backside of this part has a rib that does not have draft applied. This would have to be fixed before continuing with the mold design. Negative draft is similar to positive draft, but in the opposite direction. That is, a mold can successfully be pulled away from the part in the direction opposite of the direction of pull I specified. In most cases, red does not equal bad when using draft analysis. This part does not have what are called straddle faces. Straddle faces are those that have both negative and positive draft. We'll take a look at an example of a straddle face in a moment. Another face classification is positive steep faces. These are faces that only partially meet the draft criteria I specified. This is an example of a positive steep face. Notice that as this face nears the edge, it becomes nearly vertical and no longer meets the 1 degree draft criteria. However, the upper portion of the face does meet the criteria, making this a positive steep face. A negative steep face is similar to a positive steep face, except in the opposite direction. An example of such a face is this one here. As you might expect, we find this negative steep face on the opposite side of the positive steep face. Part of it meets the 1 degree criteria, but a portion of it fails. If you're wondering why positive and negative steep faces are not classified as requiring draft, it's because in some cases, it's acceptable to have these steep faces. I mentioned I would show you an example of a straddle face. I'll click OK to complete this draft analysis. Notice the part is still color-coded, and a key is located in the bottom right of the graphics area with the amount of faces in each classification. This way you can edit the part to fix any draft problems without having to keep rerunning the draft analysis to find any problem faces. Notice the draft analysis icon is still active in the Mold Tools toolbar. To get rid of the draft analysis colors in the graphics area, simply press the icon and the part returns to its original color.